Which is hard.
Question.
Sure.
On the homework, specifically problem 3A, where we're supposed to create a vector from 0 to 1, that one. Did you want it to create it like when you do like 0 to 1 and you do like increments of like, for example, the first set was 1.2. So would you do like 1 divided by 10 or 1 divided by 11?
We'll go over it. So there's a special function for that. So yeah.
That's interesting.
All right, it's 5:30. Let's go ahead and get started. All right, good evening, everyone. How's everyone doing today? Good, good. All right, it's week 2.
All right.
So, we're going right along. All right, so the plan for today is we're going to do a MATLAB review. And so we're going to start it today. We'll see how far we can get. And then the plan is for Wednesday for us to finish it out. Okay. All right, so announcements. Homework 1 is out there. And so I know some people have started working on it. I've gotten some questions by it already. And so I think probably after today and after Wednesday, I think it'll be a little bit easier to do the MATLAB stuff, especially if you haven't seen MATLAB in a while. So, that's the hope for, that's the hope for this week. So after this week, I'm hoping everyone feels a bit better about MATLAB. MATLAB is something we'll continue to work on throughout the semester. I don't expect everyone to be MATLAB experts after this week. Kind of the point of this week is just to kind of jog your memory about a lot of the core functions in MATLAB, how to actually use it, how to start it up. And then, throughout the semester, we'll continue building on it and seeing how we can actually use it to solve computational heat transfer problems. Okay. Are there any questions I can answer before we get started for today? Okay. All right. So today's lecture is meant to be interactive. And so if you want to pull up MATLAB on your computers that you're working on right now, you can kind of work on some of the code. I'm going to be typing code, in MATLAB today as we go along as well. Or, if you want, you can sit and watch, I'm not the police. I can't tell you what to do. So, but generally speaking, it's for these activities, kind of following along is kind of the best way. Okay, so this is our MATLAB review. You can tell I made this 2 years ago and I've yet to update the date there, but it's still relevant. MATLAB is still the same good old software as it was 2 years ago. Okay, so just a little bit of background. We're going to be working with computational engineering this semester. And so anytime you're doing any kind of computational work, you can't really get around programming. And so whether it's MATLAB or Python or C++, or even some of the older languages like Fortran, you're going to be programming to some degree. And so, for our class, we choose MATLAB, but a lot of the skills that you learn in MATLAB you can actually apply to other programming languages as well. Okay. And actually, a couple people have already talked to me in the class that they want to learn Python. And so actually, this class is a good chance to learn Python as well. So Python and MATLAB share a lot of similarities. But Python, I think overall, you can do a lot more with Python than you can with MATLAB. So, that's also a good option. Okay, so what is MATLAB? So MATLAB is, it's a programming, it's a program itself. So it's kind of unique compared to the other programming languages in that you need to run the actual MATLAB program to run MATLAB code. Okay. And, the reason it was designed was that it was designed specifically to do basically mathematical calculations. So any kind of linear algebra, differential equations, all of that good stuff. Okay. And so it was kind of designed from the ground up to be kind of easy to use. That was kind of its point. And to basically be a good educational tool. Okay. And so performance-wise, MATLAB is actually pretty slow. And so if you compare it to things like Python or C++, MATLAB is going to lose that race, 10 out of 10 times. And so MATLAB is not really meant to be something that you build a gigantic code from. And so if you look at a lot of the commercial softwares out there, like SolidWorks or like ANSYS, those codes are not built on MATLAB. I can guarantee you that. And so MATLAB is not really used for those big ones, but MATLAB has a lot of really nice features that make it a great educational tool, which is kind of why we use it a lot in the classroom. Okay. And so, just kind of reiterating some of those points, if you go to any engineering college, you'll see MATLAB probably to some degree, in a lot of the courses, because it does make it really easy. The main reason it's easy is because MATLAB has a lot of built-in kind of specific functions that kind of streamline a lot of the process for you. And so we'll go over some that are useful for our class in a bit. But without these kind of streamlined functions, you kind of have to write a lot of that code yourself. And so MATLAB, for a lot of those really common actions from MATLAB, it's just kind of just one line of code, just one command. Whereas if you're going to do it in like C++, it may take you, 20, 30 lines of code. Okay. Another nice thing about MATLAB is that the error messages that you get most of the time, they're going to be pretty useful. And so if you run a MATLAB code and there's some kind of error with it, MATLAB is going to tell you more or less what's wrong. It'll tell you, what line the code is messed up. And sometimes it'll even suggest a correction for you. That suggestion may or may not be good, but sometimes it's good. Okay. And another nice thing about MATLAB is that it's you can plot stuff with it really easily. So you can make line plots, you can make pie plots. You can a lot of the plotting capabilities that you would expect out of Excel. You can do a lot of that in MATLAB as well, which makes it really nice. Okay. Another nice thing is that it's cheap. Okay? And so you could probably buy a license of MATLAB. Probably now it's different because of inflation, but I remember it used to be about $99, which seems expensive. But then if you look at like a commercial version of like ANSYS, which literally costs like $10,000 just to use it for 1 year, $99 is not that bad for how useful it is. Okay, so let's get started. So even before we do this, and so let's talk a bit about how we actually open MATLAB and use it. Okay. And so I didn't used to go over this, and that's why it's kind of not part of the slide. But I was kind of realizing that it's useful to kind of just to get used to the MATLAB interface and kind of see it from kind of the way I see it. Okay, so if you open up MATLAB, you would come to a graphical user interface like this. Okay, and there's quite a lot of things you can do from this. Okay? So on the one hand, you have this thing called a command window, and so probably when you're first learning MATLAB, this is where you would use it from. And the idea behind the command window is that you can kind of input commands one at a time into the command window, push enter, and then it'll execute those commands. And so for instance, if we go back to the slides real quick, this first slide here is how do we define a variable? Okay, so defining a variable is kind of the most basic things you can do in MATLAB. And so if we were to type this into the command window, you would say that, variable A is equal to 7. Okay. And so what I did was I created a new variable called variable A, and I gave it a value of 7. And actually, let me increase the font here just so you can see it a bit better. Okay, is that a bit better? So it's size 14 font. Okay. Okay. And so what did I do here? So I created a new variable. I called it variable A. Okay. And so whenever you create a variable, whenever you create like an object within MATLAB that you can interact with, you can find its value here in the workspace. Okay. And so the workspace is kind of the, it's like the workspace, kind of just exactly how it's defined. And so whenever you create something within MATLAB, it's going to store its value in the workspace. So let me go ahead and clear it just to see. Okay. And so if you start a code from scratch, you can assume that the workspace is empty. Okay, so there's nothing on the workspace. But then as you create variables, as you kind of run your code, the workspace becomes populated with things that you can save. Okay. And so for instance, if we go back to the slides right here, the first thing that one of the first things that you can do within MATLAB is to define a variable. Okay. And so a variable is basically a labeled entry that's used to store information. Okay. And the types of information you can store depend strongly on the type of information that you want to store. And so the types of information you can store into a variable vary from a simple scalar And so we use the word scalar to define just a single value, so just a single number, okay? It can be a vector, and so a vector stores a collection of values organized as a list. Or something that we'll use a lot in this class is a matrix. And so matrix stores a collection of values stored as some kind of 2D construct, okay? And so to construct a variable, you need two things. And so first of all, you need to give the variable name, okay? And you need to give the variable its value, okay? And the way that you assign a value to a variable is you use this equal sign, okay? And so this here's kind of a sample code of how it works. And so, let's say that we want to define a scalar variable. So we can say that, our variable name is going to be scalar underscore example, okay? We use an equal sign. So the equal sign tells MATLAB that we want to assign a value to this variable. And then we finally give the variable its value, which is 6, okay? And then usually what you'll see for a lot of MATLAB code is that you have to end with the semicolon. And so all that does is that it makes it so that you don't print a bunch of stuff to the screen. Okay, so let's give it a try. And so, I already kind of did this, but we can do it again, okay? Okay, so remember right now the workspace is empty. And so let's go ahead and define a variable. And so let's say that I want to define a variable because I want to use this variable kind of later on in my calculation. So call this variable, called variable 1, okay? And we'll give it the value of 8. Okay, so you can see the syntax here. So I gave the variable name, so this variable's name is variable 1, okay? I use the equal sign, so the equal sign means we're going to assign, and the value that we're assigning to this variable is 8, okay? And I included the semicolon. And so I'm going to go ahead and hit enter. And then as soon as I hit enter, you can see, you can go to the workspace here, and you can see how the workspace stores this variable and its value, okay? And so, you can read kind of this workspace in kind of the same way. So we have the variable name, okay? And so the variable's name here is variable 1. And then we have the value for the variable, which is 8, okay? Just like how we defined it there. And if you want, you can double click on this on the workspace just to show you. And so for a scalar, it doesn't really do anything because, it's just a single number. But you'll see later on, once we start defining vectors and we start defining matrices, being able to double click this will show you exactly what's inside, okay? And so, as we start to use MATLAB more and more, you should become kind of well acquainted with this workspace because that's how you really kind of check, and that's how you really kind of see how your code is doing. You have to want to make sure basically that your workspace has the right values for the variables that you define. Okay, any questions on this so far? Okay, so that's defining a variable, and that's a little bit about the workspace as well. Okay, so let's go ahead and move on. Okay, so now that whenever you have a variable, you can also manipulate its value, and you can do calculations on it as well. Okay, and so another way that you can think of MATLAB is that you can almost think of it as like a very fancy calculator that you have in your computer. Okay, okay, so for example, and so let's do a mathematical operation. So in this line of code here, you can see we're defining a new variable. And so the new variable is called scalar underscore operation. And what it's equal to is 3 times scalar example. So scalar example has a value of 6 plus scalar example, okay? And so let's do the same thing here. And so we have a variable already called variable 1. And so let's create a new variable called variable operation, okay? And so instead of assigning a value straight up to this new variable, what I'm going to do is I'm going to use the old variable up there. So I'm going to do 3 times variable 1 plus, we'll say variable 1. Okay. Okay. And so what we're doing here is we're defining a new variable. And so a new variable is called variable operation. And its value is going to be equal to the result of this mathematical equation, okay? And so to evaluate this, you would evaluate it algebraically just the same way as you would, any equation. So you would take variable 1. You can see that variable 1 has a value of 8, and so we'll go ahead and plug in a value of 8 here for variable 1. So that's 3 times 8. 3 times 8 is 24, okay? And then we're going to add the value of variable 1 again. And so we're going to have 24 plus 8. 24 plus 8 is 32. And so as soon as I hit enter here, you should see a new variable pop up in this workspace, and its value should be 32. Okay. All right, I went ahead and hit enter. And so that executed this line of code. And so you can see here that we've defined a new variable called variable operation. You can see it here in the workspace, and its value is 32. Okay. All right, so variables, I think people kind of get confused with variables because, as you write more and more complex code, you're going to using, tons of variables here and there. But just remember that variables are nothing more than just, kind of representations for other values. Okay. And the reason we use variables is just mostly so that we can store their values. Okay. Right, and so those are a couple examples for how you create variables for scalars. But like I mentioned before, you can use variables for vectors as well. Okay. And so to define a vector, you would basically use the square bracket notation. Okay. And so to denote a vector, you would do square bracket, and then you would list the values, all of them separated by a comma, and then you would end it with the closed bracket. Okay. And then you can do addition and subtraction on vectors as well. Okay. And so let's see this in action. So let's do vector variable. And let's just make a 3-digit or a 3-entry vector. Okay, so we'll just do 1, 2, 3. Right, so this vector, we say this vector has 3 entries. Okay, and so we have 3 entries here. And the values of those entries are going to be 1, 2, and 3. Okay, so I'm going to go ahead and hit enter. And this vector here is pretty small, and so it only has 3 entries, and so we can see its whole value here. But if I were to make a bigger vector, I'm spamming this for now. Okay. I'm just doing this as an example. Okay. And so you can see here I have a 25 entry vector. And so that's kind of too big to fit here. So if you look at the workspace, you can see that it registered this variable as bigger vector, but it has too many entries to list here. And so if you want to see its value, you can simply just double click it. And then you can see the value of all the entries in this vector. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, 2, 3, 4, blah, 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 all the way until entry 25, which is 9. Okay. All right. And so like I mentioned before, we can do vector addition as well. Okay, so I'm going to create a new variable called vector addition. And let's say this is going to be vector variable. Okay. And so we're going to get the small vector variable that we had up there. Okay. And let me do this. And so we're going to do vector variable plus 5 times vector. Okay. And so we have vector addition here. So we have one vector, which is just, our old vector variable, which is 1, 2, 3. And then we have another vector here, which is our same vector from before. So 1, 2, 3, but we're multiplying it by 5. Okay. When you multiply a vector by a number like this, what happens is that you take that scalar value and you multiply by every entry in the vector. So this is also going to be a 3-entry vector. Okay. So let me go ahead and draw it here, where each of the entries here are going to multiply by 5. So the first entry is going to be 1 times 5. So 1 times 5 is 5. The second entry is going to be 2 times 5. So 2 times 5 is 10. And the third entry is going to be 3 times 5, which is 15. And so you can do, I call this kind of scalar multiplication. So you can take a scalar, multiply by a vector or a matrix, and then it's going to multiply all throughout. Okay. Okay, so let's go ahead and enter. Okay. And we can see kind of the result of this code. So we can see vector addition here. And so the result is a 3-entry vector just like before, and its entries are 6, 12, 18. And so that's exactly kind of what you would expect for adding 2 vectors like that. Okay. Any questions on this so far? All right, fairly straightforward. Good. All right, let's come back to the slides. Okay. Let's start to get into some specialized functions. Okay. And so, one way to define a variable is to, do it like this, which is basically, I call this kind of direct specification, okay, where you know exactly what the value or values are, and you set it, kind of manually like this. Okay. But sometimes you want to have a vector that kind of follows a certain pattern, but you don't want to write every single entry. Okay. So there's some special functions here that kind of help us out in defining these kinds of vectors without us having to kind of go through the trouble. Okay. All right. So the first one that we'll define here is called linspace. Okay. And so linspace is a special vector that where you can specify the starting value, you can specify the ending value, and you can specify how many entries that you want to have inside that vector. Okay. And so, for example, we have this example here where we say we have linspace 0, 10, 5. Okay. So this tells MATLAB that I want a vector where this first entry is 0, the last entry is 10, and I want this vector to have 5 entries, and I want all the entries to be evenly spaced from each other. Okay. And so MATLAB's like, okay, I got you. And so it creates this new vector for you where the first entry is 0, the last entry is 10, and then it fills in all the other entries in the vector such that they're all evenly spaced. Okay. And so for this particular example, the spacing between them is 2.5. And so by executing this command here, we have a vector that goes 0, 2.5, 5, 7.5, and then 10. Okay, so 5 entries, first entry 0, last entry is 10. So this kind of fits the bill for that, command. Okay. Another special function that we're going to use a lot is the zeros function. And so the zeros function creates a vector or matrix that's all zeros. Okay. So for instance, let's say that you wanted to create a vector with 100 entries with all of them being 0. Okay. And so one way that you can do this, so we call this the dumb way. And so one way that you can do this is you can have one finger on the 0, the other finger on the comma, and you can just do this. Okay. Write this keyboard here. Okay. So obviously that's not feasible. Okay. Unless you really like typing and you hate your keyboard for some reason. But if you wanted to make it another easier way is to use this command. Okay. And so we can say zeros vector is equal to zeros 100 by 1. Okay. And so this tells MATLAB that I want a vector with 100 rows, okay, and 1 column, and I want all of them to be 0. Okay, so I'm gonna go ahead and hit enter. Let's go ahead and look at this. And so when I double click zeros vector, you can see here that there's 100 entries in the vector, and they're all 0. Okay. So that's kind of a nice shortcut whenever you want to create a vector or matrix of all zeros. And that's something we're actually going to do a lot in this class. So you'll see the zeros command quite a bit throughout the course. Okay. Any questions on this so far? Okay. Okay. Manipulating variables. And so, once you set a variable's value, you can actually change its value. So it's not fixed. It's not fixed at all. Okay. And a lot of times you actually want to do that. And so you want to basically set a variable value. You might use it for some calculations, but you might change it later. Okay. And that's totally fine. And so the way that you change a variable's value is that you use the same kind of syntax as before. And so use the equal sign. Okay. And so what's going to happen if you use the equal sign on a variable that already has a value? It basically overwrites that old value. Okay, so let's do an example here. So let me take variable 1 here. Okay. So, kind of the first line of code that we wrote here was that variable 1 is equal to 8. And so that tells us that variable 1 has a value of 8. Okay. Let's say that I changed my mind. So let's say that I want variable 1. Let's say I wanted to have a value of 5 instead. Okay. Okay. We can do that. That's totally fine. And so let's go ahead and hit enter. Okay. And it may have happened pretty quickly, but if you look on the left right here, you can see that variable 1, its value is 5. Okay. And you can do this as many times as you need to in your code. So, And so reassigning a variable's value is something that happens pretty common. And we'll do a few examples of like kind of worked code where that's really useful. Okay. But I want to draw your attention to something. And so, we've changed the value of variable 1. And so the question, that always occurs is that, is that going to change the value of any other variables that depend on variable 1? Okay. And so in particular, we had this other variable here called variable operation. Okay. We said that variable operation is equal to 3 times variable 1 plus variable 1. Okay. And so the question is, when you reassign a variable value, does that change the value of any other variables that are dependent on it? Okay. And obviously the answer is no, because you can see in the workspace here that variable operation still has a value of 32. Okay. And so when you change a variable's value somewhere later in the code, it doesn't affect any of the code above it. Okay. And so that's a theme that we're going to be talking about today as well, is that, whenever you write a MATLAB code, it's always executed sequentially. So it goes from the top and it goes to the bottom. And once a line of code is executed, it doesn't go back. It doesn't go back, okay? Unless you have a loop or something like that. And so if we wanted to basically update the value of variable operation to match our new variable, we would basically have to repeat that line of code. And so we'd have to basically write again. Variable operation is equal to 3 times variable 1 plus. Okay. So all I did was I just retyped this line of code right here, our second line of code, exactly as it was before. I could have just copied and pasted, but I'm an idiot. Okay. And so when I execute this code, this is actually going to change the value of variable operation because variable 1 now has a value of 5. Okay. And so when I execute this, variable operation will turn into a value of 20. Okay. And if you kind of were watching kind of carefully, it did exactly that. So variable operation now has a value of 20 because we re-executed that line of code after we changed the value of variable. Okay. Okay. Right. And so, that's fairly straightforward. So that's, just kind of manipulating variable values. Okay. But this next technique, I think, is going to be really important. This may be something that you may not have used in a previous course. Okay. And so a lot of times we want to update a value of a variable. Okay. So not only do we want to replace it, or instead of replacing it, we want to take what it was before and either add or subtract to it. Okay. So I call this the update notation. I don't know if it actually has a real name, but I call it update notation. Okay. And it looks something like this. And so, let's say that we want to take a variable and we want to add 9 to its current value. Okay. And so we would write a line of code that looks like this, where we would have the variable name. We would have an equal sign. We'd have the variable name again, and then we'd have the variable and we have the value that we want to add to it. Okay. And so it looks, at first when you kind of look at it, it looks a little bit disorienting because you have the same variable name on both sides of the equation. But for the variable name that's on the right, you can almost kind of consider that to be the old value of that variable. Okay. And so let me do an example here. So we have variable 1. So variable 1 is equal to 5. Let's say that I want to define, I basically want to update variable 1 so that we add 9 to it. Okay. So we have variable 1 plus is equal to variable 1. Okay. And then we're going to add 9 to that. Okay. And so the way to kind of read this code, it is a little bit weird to have the same variable on kind of both sides of the equal sign. Is the way to read this code is that the new value of variable 1 is equal to the old value of variable 1 plus 9. Okay. And so if we look, we can see the old value of variable 1 here is 5. And so 5 is going to go into this equation right here. Okay. And so what we're going to say is the new value of variable 1 is going to be equal to 5 plus 9. Okay. And so this should be 14. Okay. So kind of watch kind of very carefully on this side of the screen right here, variable 1. Okay. So I'm going to go ahead and hit enter, and that's going to change into 14. Okay. Just like I said, we've updated its value to 14. Okay. All right. So this syntax right here, this technique of updating a variable name, we're going to use quite a lot in this course because there's going to be times when we're going through a loop or we're going through a code and we're just kind of updating a value. This is especially true when we have what's called counter variables, which are variables that kind of keep track of a certain value, and we basically want to add to it as we go through the code. Okay. All right. Any questions on this so far? Sense? Okay. Okay, so let's talk a bit about how we actually use variables. And so, we've talked a lot about, how we create variables, how we manipulate them, how we assign their values. Okay. So how are they used in a program? And so, I would say variables kind of form the backbone of any kind of program that you write. Whether you're writing a program to simulate, computational heat transfer, or you're writing an app to, I don't know, keep track of your bank information. I don't know. And so there's always going to be variables. And so, variables are used in a lot of different ways. Right? And so the first way that a variable can be used, and and we'll use variables like this a lot in this course, is to store kind of important, I call them kind of problem parameters. Okay. And so, as we kind of go through the class, we're going to be, solving for heat transfer in a solid, in a fluid. And so we're going to need to store things like the thermal conductivity, like the convection coefficient, like the convection velocities. Okay. And so a lot of times these are kind of variables or kind of numbers that define our physical problem. And so we need to store them in variables so that we can actually use them in the program later. Okay. So that's one way we can use variables. Okay. Another use for variables is that, we're going to be doing a lot of calculations in this course, calculations in MATLAB. And so variables are often used to basically store the result of these calculations so that you can use those results later. Okay. And so the second use there is kind of more like a calculator, basically. Okay. All right. And so the last tip, before we kind of move on from variables is that, it helps a lot, and trust me on this. And so I know, it's very easy to get kind of lazy when you're writing code. But if you kind of do make the effort for this, it makes your life just so much easier. And so when you're writing code, really put in effort to think of really distinct and descriptive names for your variables. Okay. And so if you notice from the code that we've written so far, I've used kind of long variable names. And so I call this variable 1. Okay. And so I very easily could have, written all this code like this. So I could have done, A is equal to 8. B is equal to 3 times A plus A. C is equal to 1, 2, 3. Okay. Okay. So I'm basically recreating this code, but with crappier variable names, right? And so it's very tempting to use variable names like this because it's a lot faster to type. But trust me when I say this, you will be cursing yourself and you will end up spending more time on your code if you use variable names like this. Okay. Because I will tell you that, when you're writing a code, and maybe some of you kind of know this already too, the most time that you spend on your code is not actually typing. Okay. The typing part is actually probably what you only spend about 5% of your time doing. What you spend 95% of your time doing is, debugging your code, figuring out, what the heck did I do, what went wrong, and all that stuff. Okay. And I will tell you that debugging goes a lot more smoothly when you use descriptive variable names. Okay. If you write code that just has, single variable names like X, Y, K, small variable names like that. For small codes like this, it's not that big a deal. But when we get later on in the class where you're writing codes that are 400 lines long, 500 lines long, 600 lines long, having single letter variable names is going to kill you because you're going to look in your code, you're going to have some really complicated equation like 4 times A minus pi times 4 times 5 times B minus 600 times C plus 999 times D, stuff like that. Okay. You're gonna have a really complicated equation like this. You're gonna look at it because you think there's something wrong, but you have no idea where these variables are coming from because you gave them kind of crappy names. Okay. And so, I'm telling you now, you're probably not going to listen to me until 6 or 7 weeks in, but trust me, when I say, having descriptive variable names helps a lot. Okay. Otherwise, you're going to end up like my grad school code. And so, And so, you know, I never show people my the code I wrote in grad school because it's filled with a lot of stuff like this. And so, you know, you don't want to have single letter variable names, and you don't want curse words in your code as well, because usually people are going to read. Okay. All right. Any questions on this so far? Okay, so let's talk about matrices. So matrices, you know, matrices are going to be really, really important for this class. And so that's why I kind of separated it into its own section. Okay. And the reason for that is because, you know, we're going to be defining a lot of linear algebra problems. And so, you know, what you'll see from a lot of our techniques, like finite difference, finite volumes, basically the goal for a lot of these techniques is to take a complicated differential equation, like the heat equation, like Navier-Stokes, and turn it into a linear algebra problem. Okay. Basically, you're solving a set of linear equations. And so, you know, 5 equations, 5 unknowns, 500 equations, 500 unknowns, something like that. Okay. The reason we do this is that computers, turns out, are really, really good at linear algebra. So if you can take a problem, any problem, it doesn't even have to be heat transfer, and transform it into a linear system of equations, then there's a very good chance the computer can help solve it for you. Okay. And you'll be surprised that, you know, a lot of, basically a ton of computational work kind of boils down to, you know, how can I turn this problem into a matrix? Okay. And so I think kind of the hot topic nowadays is kind of like machine learning, artificial intelligence, AI, stuff like that. And so you'd be surprised. And so the way machine learning and AI works is that it takes a complicated problem and turns it into a linear algebra problem. That's all it kind of really is. Okay? And so if you're doing any kind of computer programming around these, you need to know how to work with matrices. Okay. The nice thing about matrices in Matlab is that Matlab makes it very, very simple to define matrices. Okay. And so the first way to define matrices is to kind of do it the direct way, which is kind of the way that we've learned so far. Okay. And so you can use kind of the square bracket notation that we did for vectors. Okay. The only difference is that, you know, a matrix is kind of a two-dimensional structure. And so usually the way that you define a matrix like this is that you kind of go row by row. And so you start with kind of the top row. You kind of write all the entries in that row separated by a comma. Okay. And then when you want to go to the next row, you use a semicolon. Okay. Okay. And so for this example here, you can see I'm defining a 3x3 matrix. Okay. So the first row is 1, 1, 1. The second row is 9, 9, 9. And the last row is 4, 6, 8. Okay. Okay. So let's see how that is done in Matlab. So actually, let me go ahead and clear this just to kind of clean up our workspace a little bit. Okay. If you want to clear your workspace, the command I use is clear all. And then if you want to clear your command window, the command I use is CLC. And so usually when you're starting something new, it's a good idea to kind of clear your workspace. Okay. So let's define this matrix variable. And so I'm going to define the same matrix that I have in the slides. And so we're going to have 1, 1, 1. Okay. Okay, so our first row is going to be 3 entries. And so it's going to be all ones. Okay, so I separated those entries with a comma. And then when I'm ready to go to the next row, I use the semicolon. Okay. Second row is going to be 9, 9, 9. Okay, so that's going to be our second row. And again, I end that row with a semicolon. And then for the last row, we have 4, 6, 8. We separate each of those entries with a comma. Okay. And since we're done with the matrix, we just end it with a square bracket. Okay. Okay, so I'm going to go ahead and run this. Okay, and so you can see that it created this new matrix variable for us. And so let's go ahead and double click this. And so if you double click that variable in the workspace, you can see here that this is the, this is the variable that we have. So we can see it's a 3x3 matrix with 1s on the first row, 9s on the second row, and our last row is 4, 6, 8. Okay. Pretty straightforward. So the only thing you really have to know about defining matrices like this is that, you use commas to separate the entries in the same row. And when you go to the next row, you use a semicolon. Okay. The thing you have to be careful about using this notation is that you have to make sure that each row has the same number of entries. Okay. And so if you try to define a matrix where, you have one row that's a bit off, okay? So let me go ahead and repeat this, the same line of code, but now I'm going to have the last row have an extra entry, okay? So it's going to have 4 entries, whereas all the other rows have 3, okay? If you hit enter, you can see MATLAB is giving you an error, okay? And so what this error tells you is that the dimensions of the array being concatenated are not consistent, okay? And so that means that, basically MATLAB is telling you that, the matrix that you are trying to define is impossible because the first 2 rows have 3 entries and the last row has 4. And so there's no way to make that work. Okay. So that's how you define a matrix using kind of the direct way. Okay. So that's really useful if you kind of know, what entries your matrix are going to have beforehand. Okay? And so basically you can basically knock it out in just one line of code, and all that is good. Okay. But actually the more common way that we're going to define a matrix in this class is that we're going to do it kind of little bit by little bit. Okay. And so oftentimes the more common way that we're going to define a matrix is we're going to create an empty matrix. Okay. And so if you remember from the beginning of class here, we have the zeros command. And so the zeros command is going to create a matrix of all zeros. In this case, it's 3 by 3. And then from there, you can assign the values of the matrix kind of one by one. Okay. So let me kind of show you this in action. Okay. So I'm going to define a new variable. We'll call this matrix variable 2. Okay. So the first thing I'm going to do is I'm going to create a zeros. I'm going to use the zeros command. Okay. And so I'm going to tell the zeros command 3 by 3. And so this is going to create a 3 by 3 matrix where everything is 0. Okay. Right. And so that created this new variable, matrix variable 2 in our workspace. Let's go ahead and double click that just so we can check its values. And we can see that it's all 0. Okay. So 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. Okay. And so to assign values in this matrix, basically we're going to use the same assignment notation that we did before, okay? Where you can consider each entry in the matrix, okay, as a single variable. And so another way that we can view this matrix, we can view it as 1. So we can say that we have one matrix here, but this matrix contains 9 different values, okay? And so we can assign each of those 9 values kind of individually. Okay? And to do that, you do kind of like matrix reference notation. Okay. And so the way that we refer to entries in the matrix, we use row column notation. Okay. And so we need to give 2 coordinates here. And so I'm going to use parentheses here to define the coordinates. And so the first entry that you, or the first coordinate that you put here, that's the row of the matrix that you want to specify, okay? And so the second entry that you're going to put here is the column, okay? So I made them kind of different on purpose, okay? So this tells MATLAB that, okay, we have this matrix variable. So we have a matrix variable 2, and we know it's a matrix. And what we want to do is that, all right, MATLAB, go to the entry that's in the first row and the second column. Okay. So that's what this kind of entry does right here. So we have parentheses 1, 2. Okay. You can almost think of those as the coordinates. And then what we're going to do is we're going to assign a value of 1 to that entry. Okay. Okay. And so, kind of same thing as before, let's kind of pay attention to this kind of side here. So right now our matrix is all zeros, but as soon as I kind of hit enter here, the entry that's on the first row and second column is going to change to 1. Okay. Okay, so let's double click this just so we can see. Okay. So now this is the result of the matrix after we ran that line of code. And so you can see here that the entry in the first row and the second column is now 1. Okay. Let's do it again for another entry. So let's do matrix variable 2. Okay. Let's do the one in the bottom right corner. So the one in the bottom right corner is the third row and the third column. Okay. This we're going to assign a value of 8. Okay. And kind of pay attention to this matrix variable too. Once I hit enter, it's going to change that entry in the bottom right to an 8. Okay. And so we can double click this just to check. You can see here that the third row, third column is now 8. Okay. All right, so I'm going to go ahead and kind of fill out the rest of this matrix. And silly me did them out of order, so now I have to do them in order. I'm just going to go very quickly, just kind of for the sake of time. But so you can see here, I'm kind of cheating a little bit because I'm using the command history. What's that? 4, 2, 6. Okay. So we'll go ahead and clear this. Okay, so what I've done basically is I've basically assigned each of the values of this matrix individually. Okay, so remember our matrix contains 9 values. And so I double click this. This has the same value of the matrix as before. All right, any questions on this so far? Okay. All right, so you might be asking, our result was exactly the same. So in both cases, we had matrix variable, we defined this matrix, we did it in one line of code, a lot less typing, okay? Or we could have done it this way with the zeros matrix and assign each variable individually, okay, or each entry individually, and we end up with the same result. So why in the hell would we do the second way when it's literally, like 10 times as much typing, okay? And so the main reason why we would do this, and the main reason why we're going to actually use a method like this, for most of the class, is that most of the time we don't know actually what our matrix is going to look like beforehand. Okay, and so the way that we actually construct these matrices are actually going to be row by row. Okay, and so when you construct a matrix row by row, this kind of method here works a lot better for that. Okay. Because what you can do is you can create kind of just like you can just create like a space. And so create just kind of like an empty matrix. And then as we go through our algorithm, as we go through our finite difference, finite volume, or whatever, okay, then what we're going to do is we're going to populate that matrix with the appropriate entries so that we can actually solve our problem, okay? All right, another reason we do this is that, you'll see very soon in our, when we do finite difference, that a lot of times when we're working with these algorithms, the vast majority of the entries in the matrix are actually going to be 0. Okay. And so actually, I kind of joke about this every year, so that when you're doing your homeworks, when you're doing the project and stuff like that, you can turn in your code that looks you can have just one line of code that does this. Okay. You can just create an empty matrix, and you will probably be 99% right, because 99% of that matrix is going to be all zeros. Okay. I mean, you won't get 99% of the points, but you will, be 99% close enough to that matrix that you're gonna get in the end. Okay. Because the reason for this is because when we do these algorithms, we're creating matrices that are hundreds, thousands, sometimes millions of entries wide. Okay, and so we're gonna have zeros matrix, not 3 by 3, but maybe like 100,000 by 100,000. Okay. For each of those 100,000 lines in the matrix are going to represent some algebraic equation. Okay. And so each row, maybe only has like 5 or 6 non-zero entries. Okay. And you kind of go through all of that. So the vast majority is going to be 0. And so if you make a zeros matrix, yes, you are 99%, true. The matrix would be 99% close, but you wouldn't have executed the algorithm at all. Okay. And so when you have situations like this where most of your entries are going to be 0, it's just a lot more convenient to start with the matrix that's empty already, and then just worry about the entries that are not going to be 0. And so that's how a lot of our algorithms, that's how a lot of our code is going to be in this course. Okay. And just another quick note here that, we can use our update notation just like before. So remember our update notation from before when we had kind of the variable name on both sides of the equal sign, okay? When we want to just update a value, we can just, use this entry. Okay? And so for instance, let's say that we want to update the second, this entry right here in the matrix. Okay. And so let's say that we want to add 10 to it. Actually, let me kind of move this here so you can kind of see it happening in real time. Remember, even though the matrix variable itself is a variable, you can consider each entry in the matrix itself as its own variable as well. Okay. All right, and so if you kind of see my code right now, we can see here I have matrix variable 2, 1, 2, and then is equal to matrix variable 1, 2 plus 10. And so what this line of code is going to do is that it's going to take the old value that was there in the matrix before. And so right now this is a 1, and we're going to add 10 to it. And so as soon as I execute this line of code, this entry right here is going to change to an 11. Let me go ahead and clear this so you can see it a bit better. So you can see that the code has updated to that value. Okay. And so we'll be doing this a lot in the course as well. So we'll be kind of adding values to an already existing entry in the matrix. Okay. All right. Any questions on this so far?
Professor, can you go back to the MATLAB real quick?
Yeah.
Okay, thank you. Just wanted to make sure.
Sure. Okay. So that's, everything we covered so far, I think is, fairly, probably basic MATLAB stuff. So, probably a lot of it you've seen, maybe with a couple of wrinkles here and there. Okay. Now we're actually going to get to interesting stuff. Okay. Which is actually using MATLAB for what it's intended to do, which is perform math. Okay. So we haven't really done much math yet. Okay. And so the first thing that we're going to learn here is how you can use MATLAB to solve a linear system of equations. Okay. And so by linear system of equations, I basically mean a set of x equations and x unknowns. Okay. All right. So a lot of times, maybe you remember from Math 250A or something, you may have a set of equations that looks like this. Okay. And so we have 3 variables here. We have x1, x2, and x3. And then we have 3 equations that kind of define the relationship between these variables. Okay. And then probably what you've learned before from linear algebra is that if you have an equal number of equations to unknowns, then you can solve those set of equations for those unknown values. Okay. And so in this case, we have 3 equations, 3 unknowns. And so in theory, if we use substitution, whatever other linear algebra techniques, I don't even know how linear algebra is taught nowadays, to solve this, then we can solve for what x1, x2, and x3 are. Okay. But hopefully another thing that you learned in linear algebra is that you can take any set of linear equations and put it into what's called matrix form. Okay. And so instead of looking at the equations like this, you would basically extract the coefficients out from the equations and then put it into something like this. Okay. And this is really significant because when you have a set of equations that looks like here on the right, you can put it into MATLAB really easily because you can define a variable that defines what I call the left-hand side matrix. Okay, so LHS stands for left-hand side, and then you can create a variable for the right-hand side vector, RHS vector like that. Okay, and then if you define the two, if you define the left-hand side matrix and the right-hand side vector like this, you can use a special operator within MATLAB called \, and that's going to solve your system of linear equations. Okay. Okay. All right. So let me do an example of this. Okay. Let me actually do this exact code. And so, to transform this set of linear equations, so let's go ahead and define these lines of code. So let me go ahead and let's close this. Clear all CLC, just to clean up our workspace. Okay. Okay, so left-hand side matrix, what was the values for that? So we had 3, 5, 7. Okay, so 3. In this case, I'm using the direct method to define the matrix just because we know what the matrix entries are ahead of time. Okay. Second row in the matrix is 1, 0, 9. So 1, 0, 9. And then the last row in the matrix is going to be -3, 1, and 0. Okay, so that looks good. Let me go ahead and define my right-hand side vector. So my right-hand side vector has 3 entries. And so our right-hand side vector is going to be 0, semicolon 3, semicolon 6. Okay. Notice how I'm defining this vector. I'm not using commas here. I'm using semicolons. Okay. Because what we need is we need this right-hand side vector to be a column vector. Okay. And so before we had row vectors, but since this case, we need them to be kind of stacked on top of each other just for linear algebra reasons. I use semicolons here instead. Okay. All right, so these two, this matrix and this vector, which we've now kind of saved as variables, they represent our linear algebra problem. So we basically want to use these to solve for our x solution. Okay. Okay. And so the way that we solve for this is that we do x solution. Okay, so we basically define a new variable to save our solution. Okay. All right, so first thing we're going to start with is our variable for our left-hand side matrix, and so we have LHS matrix. Okay. Then you put backslash, and so backslash is different. So normally you put, I don't know if you can really see. So normally you use the slash command that's next to shift, right? So backslash is the other one. Backslash is above the enter sign on the standard keyboard. Okay. Okay, so then you do left-hand side matrix backslash, and then you do right-hand side vector. Okay. Go ahead and put a semicolon. Okay. And then MATLAB is going to solve that for you. Okay. And so if you want to check its value, we can go here to the workspace again. And so you can see we can check our variable x solution here. Okay, we double click that. And there is the value of our solution. Okay. And so MATLAB is not going to label this for you. And so it's kind of up to you to kind of make sure that it's in the right order. But basically this first entry here is x1. The second entry here is x2. And this third entry here is x2. Okay. So very useful. And, I think this may not be taught in Math 250A because, probably literally cheat the entire course using this method. Maybe I know some of you have this functionality in your graphing calculators too. But just know that it's you can use it in MATLAB too. So this is how you solve linear equations. We'll be making use of this a lot in this course. Okay, and you can see, for situations like this where your x values here are not very nice numbers. You can see these are kind of gnarly fraction or gnarly decimals here. Having a calculator, having MATLAB do this for you is really, really nice. Okay. The only thing that you really have to know how to do is you basically just need to know how to set up the equations. Okay. All right. So that's solving a system of linear equations, and so definitely remember this because we're going to use it a lot. I think it's the first problem in the homework as well. Okay. All right. So for the rest of today, we're a little bit ahead of schedule. I was thinking we'd probably do this next time, but for the rest of today, we're going to talk about the actual programming part of MATLAB. Okay. Which is using things like if statements, else if statements, else statements, and for loops. Okay. Okay. So let's start with if statements. Okay. All right. So now that we kind of have the basics of MATLAB down, we know it's how to define variables, how to manipulate them, how to solve linear equations. We're starting to get ready to write kind of more complex programs. Okay. And so there's a lot of programming constructs that you can use to kind of make sure that your program kind of does the right things and your code is written effectively. Okay. And so the first one we'll go over is if statements, which I think chronologically is probably the first thing that you kind of learn in a programming course. Okay. And then we'll go over for loops next. Okay. All right. So what are if statements? And so if statements are basically tools that you can use within a program if you want the program to do different things. Okay. Because a lot of times, you're writing a program and you're not sure how the program is going to go, okay, in terms of, what it should do. And so in situations where, you want the program to do different things in different situations, you can write if statements to kind of, denote that, okay? And so here's kind of the general structure of an if statement. And so, it starts with if. And so as soon as you type if within MATLAB, it's going to turn blue. And so whenever you see something in MATLAB turn blue, that is a keyword. Okay. And so next to the if, I personally like to use parentheses. I like to kind of surround my if condition in parentheses. It's optional. I know it's kind of a personal preference thing. And so if you prefer not to use parentheses, that's fine. But for all the code that I write, you'll see me use parentheses just because I'm a little bit of a parentheses kind of paranoid word for these kind of things. Okay. All right. So you have if, and then inside the if, you're going to have what's called the check condition, which we'll talk about in a second. And then inside the statement itself, you're going to have some lines of code, which is going to be performed if the if statement returns true. Okay. And then when you're done with the if statement, you write the keyword and. Okay. All right. And so let's talk about this check condition. So this check condition is something we call a Boolean expression. Okay? And so a Boolean expression is something that can either return true or false. And so it's one or the other. It's not like it's not maybe, or it's not my wife when when I ask her what she wants to eat, she's like, oh, I don't know. It's either true or false. It's one thing. Okay. And so if the check condition is true, then we go into the if statement and we perform the code. If not, then we just don't do anything. Okay. All right. And so even though in this kind of sample here, I only have one line of code inside the if statement, in reality, you can have as many lines of code inside the if statement as you want. Okay. And we'll do kind of multiple examples for you. Okay. And so again, if the check condition was false, then the code just kind of immediately moves on to the next thing. Okay. All right. So here's a couple examples. And so a lot of times you'll have if statements based on the values of certain variables. Okay, so this is kind of very, very similar to kind of the cases you'll see in this class. Okay? And so you'll be having a variable. That variable will have its value updated. It'll have its variable kind of calculated throughout the code. And then when you reach a certain other part of the code, you want the code to do one thing or another based on the value of that parameter. Okay. And so let's look at these examples. And so on this first example here, we have this variable. And so we have this variable called needs correction, okay? And so we set the value equal to 3, okay? And then we come to the if statement. And so we check to see if this variable needs correction. If it's less than 5, then we're going to go into the body of the if statement, okay? And so let's plug it in C. So needs correction, we know its value is 3, okay? And so we plug in 3 into this if statement here. And so we say if 3 is less than 5, is 3 less than 5? Of course, 3 is less than 5. Okay. And so we go into the body of the if statement, and so we correct its value to 5. Okay. All right. So let's see this in practice. Okay. And to kind of make this a little bit easier, I'm going to write it all into a script. Okay. So up to this point, we've been using what's called the command window in MATLAB, where you can literally just execute commands one after the other. But most of the time, you're going to want to write a script, okay? Because you want to basically, you want to write a bunch of code and then MATLAB to execute all of them kind of at the same time, okay? And so when you're doing things like if statements and for loops, it's usually a lot easier to use a script rather than use the command window, okay? Okay. Okay. And so we define a variable here called needs correction. And so we set his value to 3. Excuse me, sorry. Need water after this. That's my wife. She's mad at me because I made fun of her. Okay. All right. And so we have this code here. All right. And so in this case, we have needs corrections equal to 3. And so this is kind of the initial value for that variable. And then what we're going to do is, sorry about that. If this variable's value is less than 5, then we're going to correct it. Okay. All right. So what I'm going to do is I'm going to save this code. And I'm going to run it. Oh, here. All right, let's go ahead and run the code. All right, so when we run the code, you can see that the value for needs correction is 5, right? And so the reason for that is that our if statement here returned true. And so when our if statement is true, then we jump into the body of the if statement and we correct the value of the variable. Okay. We said its value to it's a 5. All right. 10 more minutes. Okay, I can get through this. Okay. Sorry, wife. Okay. And so right. So that's what happens when the if statement's true. When the if statement's false, we kind of just ignore everything within the if statement. Okay. So now let's try the same code, but now we're going to set the value equal to 9. Right. Okay. And so let's examine this code before we run it. And so we set this variable equal to 9. Okay. We go to this if statement here. And so we check its value. Okay. And so we check to see. So if 9 is less than 5, that's something that's false. Okay. And so since that's false, we're going to ignore everything within the if statement. And then needs correction is going to stick with its original value. Okay. And so we run our test code. And you can see that even though within the if statement, normally we would reassign the value of needs correction to 5. But since the if statement returned false, it still retained its original value of 9. Any questions on this? Okay. All right, so that's basic if statements. Okay. All right, so let's talk about else if. So a lot of times, when you write an if statement, there's kind of more than one condition that you want to check. Okay. So in the case when the first condition fails, maybe you want the program to do something else if a second condition is met. Okay. And the way you do this is with an else if. Okay. All right. So the basic structure of an if else if statement looks like this. Okay. And so there are at least 2 conditions that you need to check. And so first you check condition 1. And so you say if condition 1, and if condition 1 returns true, then you do the work here, okay, to execute these lines of code. Okay. And actually, if that's true, if condition 1 returns true, then the only code that you execute is the code that's between the if and the else if. Okay. But let's say that condition 1 returned false. And so if condition 1 returned false, then we move on to the else if condition here. Okay. And so the next thing we check is condition 2. And so if condition 2 returns true, then we execute what's inside the else if statement, which is right here. Okay. So that's kind of how an if else if statement works. Okay. But this gets a little bit complicated because, because now you have multiple conditions that you need to check. Okay. So let's do some examples here. Okay. So let me go ahead and clear this. Go ahead and clear. So let me go ahead and copy this code here. So we would say needs correction up here. Equal to 11. Say if needs correction less than 1. Okay. One else if okay. So here we have an if else if statement. And so basically what this is saying is that, we have a variable here. And so this is kind of the variable in question, just like before. Okay. And so if that variable's value is less than 1, then we're basically going to correct that value, the value of that variable to be 1. Okay. Whereas if if that variable's value is greater than 7, then we correct the variable's value to 7. Okay. Okay. So let's kind of take this kind of line by line here, kind of based on the values that we have. Right. So first we have needs corrections equal to 11. Okay. And so let's check the first if statement. So the first if statement here is if needs corrections less than 1. Okay. So obviously 11 is not less than 1. And so we're going to go ahead and just ignore this first part. Okay. Right, so the first if statement there returns false, and so we're going to ignore that part of the code. Okay. Next, we check to see if needs correction is greater than 7. Okay. So we look at 11. So 11 is greater than 7, and so this is going to return true. Okay. And so since the else if statement returned true, then the code that we're going to execute is here. Okay. Okay, so let's go ahead and try it out. And so based on kind of our analysis here, our variable needs correction here should have a value of 7 by the time we execute this code. Okay. Okay, so we ran the code and we checked the workspace. And so indeed, we can see that our variable here needs corrections equal to 7. All right. Let's do another example. So let's say that our variable here needs correction. We're going to start with a value of 0. Okay. Okay. And so we run through the if statement here. So we can say, we can check the first one. If needs corrections less than 1. And so that is indeed the case. And so since 0 is less than 1, then we're going to correct its value to 1. Okay. So this is true. Okay. And so since this is true, we're going to execute this line of code right here. Okay. Okay. And at this point, it doesn't even matter. And so it could be that this else if statement is going to be true as well. In this case, it's false. Okay. But it doesn't even matter if the else if statement is true or false, because if the first condition here is true, then it just executes this and it just ignores everything else. Okay. And so according to this, when we run the code, needs correction should have a value of 0, or excuse me, it should have a value of 1 by the time this code exits. So let's go ahead and run the code. Okay. And let's go ahead and check the value of needs correction. And so needs correction indeed has a value of 1. Okay. Right. And so like I mentioned before, that you have to be really careful with this if else if statements, because you're going to run into situations where maybe this first part for the if statement is true, and maybe the second part with the else if is also true. Okay. And so you might be tempted to think that maybe both lines of codes are going to be executed, right? But that's not true. And so when you have an if else if statement, okay, then only one part of the if statement is going to be executed. So in this case, only the first part is going to return true. Okay. And so last example, what if everything is false here? Okay, so let's go ahead and change this value to 3. All right, so let's do the same thing. So let's run through each of the statements here. Okay. First, we're going to check if 3 is less than 1. Okay, is 3 less than 1? No. So this is false. Okay. Next, we check to see if the variable's value is greater than 7. So we check, is 3 greater than 7? No. So this is false as well. And so in this case, nothing inside the if statement is going to execute because it's all going to be false. Okay? And so by the end of this code, the variable here needs correction is going to maintain its original value because we don't execute any of these other lines of code. Okay? So let's go ahead and run it. Oops, did not mean to do that. Okay. And so if you check here in the workspace, that is indeed true. And so our variable here still has a value of 3. Okay. All right. Any questions on this before we wrap it up for today? Okay, all right, so that's all we got time for today. And so on Wednesday, we'll pick this up again and we'll get and finish up this review. And so there's only a few more left. And so there's else statements and there's for loops. And then there's a couple examples that I want to run through as well. Okay. All right, but with this, you should be able to get a good start in the homework. And so just go ahead and get started on that. So thank you guys for coming today. I apologize for, well, I guess I apologize for insulting my wife and then her giving me divine retribution. So, I'll make sure not to do that next time. Right? So have a good evening, everyone, and I'll see you guys on Wednesday.
Professor,
Yeah.
for 5:40, I'm on the wait list, and I'm gonna need the Zoom link for that.
Okay. Yeah, I'll get it
again.
Let me get it right now.
Thank you.
I just expanded the course today, so it might just be processing in the system, but you should be in the class by tomorrow.
Okay. Okay,
there's the
Thank you.
yeah. Mhm.
See you in 15 minutes or
Yes.
whatever.